Hello everyone. Welcome to the solution of LeetCode problem 563 named binary tree tilt. In this problem, we are given the root of a binary tree and we have to return the sum of every tree node's tilt. Here, what is tilt? A tilt of a tree node is the absolute difference between the sum of all left subtree node values and all right subtree node values. And here, if a node does not have a left child, then the sum of the left subtree node values is treated as 0 and same for the right child also. Now here, in the first example, you can see that the root is 1, which is 2 children, 2 and 3. Now here, for the node 2, it does not have any of the left or right children. So the tilt value is 0 minus 0, which is 0. For this node 3, similarly, it does not have any of the left or right children. So the difference will be 0 again. But for this node 1, its left subtree sum would be 2 and right subtree sum would be 3. So the absolute difference will be 1. So here the total tilt of this tree will be 0 plus 0 plus 1. So here we have to return 1 as well. Now, I hope you understood the problem statement. Now let's move on to the algorithm. In this problem, to understand the algorithm, we have taken this example. Here, the root is 4, which is 2 children, 2 and 9. 2 has 2 children, 3 and 5. 9 has 1 children, which is 7. So here, we will apply the depth first search mechanism to find the tilt. So here in the DFS, we will traverse the left subtree. The starting position is here, which is root 4. Now we are in this node 2. Now we are in this node 3. So here node 3 does not have any of the left or right children. So its left or right children will return 0 as both of them are null. And node 3 will return 0 plus 3 plus 0, which is 3. Now, from these two, the call will be in this node 5. Similarly, it does not have left or right children, or we can say that its left and right children is null. So both of them will return 0. And 5 will return 0 plus 5 plus 0, which is 5. And 2 will return 3 plus 5 plus 2, which is 10. Now, from 4, the call will be in node 9. 9 does not have any of the left children, so its left children will return 0. Now, from 9, the call will be in this node 7. Its both of the left or right children will return 0. And node 7 will return 0 plus 7 plus 0, which is 7. And node 9 will return 7 plus 9, which is 16. And finally, 4 will return 4 plus 30 plus 16, which is 30. Okay. Now, as we can see that for each of the node, we have the left and right subtree return value. So in each of the node, we can calculate the answer. So here at first we will take a answer variable which will be initialized with 0, and in each of the node we will add the absolute value of left subtree value minus right subtree value. For this node 3, it will be 0 minus 0. For this node 2, it will be 3 minus 5. For this node 9, it will be 0 minus 7. And for this node 4, it will be 16 minus 10. So here, for each of the node, we will calculate the difference between the left and right subtree values. And finally, we will add them into the answer. And we will return the answer as well. Here, I hope you understood the algorithm. Now, the overall time complexity of this problem is big O of n, where n is the number of nodes. I hope you understood the algorithm. Now let's move on to the code. In this problem, the code is pretty simple. At first, we are given a function named findTilt, which has a root as a parameter. Now we are calling a DFS function into this root and initializing an answer variable with 0. Now here, if the root is null, we have to return 0. Otherwise, we have to call the DFS function on the left and the right subtree and store the return value into the variable left and right. And here, we have to upgrade the answer, which will be answer plus equal to absolute of left minus right. Now for each of the node, it will return the summation of its value plus left children value and summation of all of the right children value. Finally, we have to return the answer. I hope you understood the code. Thank you everyone for watching the video. We will get back soon with another LeetCode solution.